Hello everyone, today I will provide information about stair modeling in the STA program. We have 2 stair examples. These are samples taken from architectural projects. The first example is a circular stair like this. First, we will carry out its modeling. Next, we have a straight stair. I will provide information about the modeling of a straight stair. Yes, now we can start modeling the circular stair. As we examine our stair, it is seen that it is connected by walls on both sides. A beam has been placed in between, and here, a slab continues as well. Therefore, we will have beams here, in the same way. Here you can see the stair steps, as you can understand from the arrow sign here. You start going up the stair, from this direction, and finally, transition to the slab from here. So this is the upper floor. The beginning of the stair will be on the lower floor from here. You can understand this from the arrow sign and this starting mark. Here are our dimensions as well. Based on these, I created my axes in the STA program. We will model the walls before our stair. They are size 25 by 265 then. I will model the beams after that. I will model the slab here. Finally, I will model the steps of the stair here. I would like to mention something before moving on to the modeling. The heights, or the number of steps, in the models here may differ somewhat from what we will model in the STA program. These differences will not affect anything from a static perspective. A slab element is important for stairs. From a static perspective, it is crucial to model it correctly and to check the stresses here. Here, of course, we will model the walls. We will set up the system correctly from a static perspective. When we model our stair later, the number of steps here may not match exactly. There will be no issues from a static perspective. Yes, first we are creating our walls. Our walls will be 25 by 265 in size. Yes. We are taking the same wall and copying it. Yes, we have created both of our walls now. Yes, now, let's model our beams with a width of 25 centimeters and a depth of 60 centimeters. Here, we are entering the dimensions related to the relevant beam. This is how we carry out our modeling. Similarly, we also model the beams that continue from the wall. After completing the modeling of the relevant beams, I will now move on to the slab modeling. First, I will model the slab here. After that, I will carry out the stair modeling. Yes, here we come to the slab part. I will choose the slab to be 15 centimeters. Here, I enter the value for dead load as 0.35 according to our regulations. After this, look here, I have also created my step. In this way, as you can see, the upper part has already been formed. Now we will create the main sections of our stair. As can be seen from the shape here, our stair is 1.20 meters wide. When modeling the stairs, look, we have our macro here. You need to model with this macro. When we click on the macro, you can see options here for stair arms, corner health in circular, stairs. Here, I will choose the circular corner stair because our stair was like this. It wasn't a right angle. I won't choose the right angle. If I choose the right angle, I won't be able to create the spaces here. Therefore, the most logical option right now will be the circular corner stair. As you can see, when we draw our stair, the codes start from the top and go down. Therefore, our stair must have an upward step. Since it is on the left side, I will start the drawing from here. But I will first set the width to 1.20. I will take the radius as 0. Here, of course, depending on the architectural project, you can use different values. While modeling, I have shown an example and I am performing my modeling accordingly. Yes, this is an important point we need to pay attention to while modeling. Look, we need to model up to this point. After this, we are now entering the area of the beam. If we model it this way, it will be an incorrect modeling, therefore, we will model up to this point. If we want to obtain accurate results, we need to pay attention to such situations when modeling the stairs. Here, we also have the direction of our stair, which side it will be drawn from. Look, the plus is selected right now. If I select the minus, then it will be drawn from here, which is what I want, but I always choose the other way, so I select the plus. And of course, we have already selected the circular corner, which is important. After that, I drew it like this, and after drawing it, I continue to draw. As you can see, it automatically provided the circularity. Then, when we come back here, yes, the circularity here became 60. And the width was set to 1.20. After this, we need to press the OK button. Otherwise, this is how you model the stair. We have modeled our stair this way. As I mentioned, the architectural project is very important when modeling the stair. If the area provided in the architectural project is not sufficient for the stair to fit, you will face problems in placing the reinforcements, and the analysis results may indicate that your stair slabs are inadequate. It is very important for the reinforcements to connect to the shear wall and for the stair to be attached to the shear wall. As we mentioned while modeling, we will not cross the boundary of the shear wall or the entrance. And here, in order to avoid any issues with the connection, it is beneficial to ensure that the flooring sections are properly connected to the shear wall. Here, we have an option that should definitely be considered when we come to the analysis options. We have our FEA analysis options button here. You definitely need to enable this option, as seen here. The option for linking the stair strings at the edge of the shear wall to the shear wall must be checked. In this way, if your slab is not connected to the shear wall, it will be connected through the link element. Additionally, we have one more option at the bottom. That is the button to reduce eccentricity in the FEA analysis of the stair supports. I recommend that you click it. After shaking these in this way, our stair is now ready for analysis. I am recording again here. Analyzing the structure. Yes, our analysis has concluded. You can now view the FEA analysis results here. As you can see, the connection to the shear wall has been made here with link elements, and since I have implemented it correctly in the model, there is no inadequacy in any of my elements. Of course, there is another important point here. As you know, we modeled the slab here with a thickness of 15 centimeters. Similarly, we need to ensure that the other parts are also 15 centimeters and should be the same. In this way, we need to model all elements of the stair with the same thickness. Now, if we come to the part about obtaining the results from the printer after the modeling is done. In the Structure Graphics Output section, there is an FEA analysis report related to stairs. Here, we can view these when we click on them. The FEA analysis report shows the design movements that are presented here, and the program also displays the required reinforcement areas in the same way, this way. Finally, it shows the assigned reinforcements related to these. Here, we can also make adjustments. Regarding the diameter of the stair, reinforcement. So how are we going to do this? You actually have the chance to make adjustments before analyzing these. If I return to the modeling part here, here, you come to the options section. Yes, as we mentioned earlier, they are modeled as individual slabs in the stairs. Here are the slab options. When we get to page 2, you can see the minimum stair reinforcement diameter here. Here, a minimum diameter of 10 millimeters has been entered for the reinforcement. Therefore, as already shown in the report, all the reinforcement has been placed. Here, if you want a different diameter, you can change it yourself from here, and then perform the analysis. Again, of course, you can obtain the drawing of the stair in the formwork application plan. I am coming to the formwork application plan here. Yes, I am adjusting my scale. After I adjust it, look here. When I draw, I get the reinforcements of the stair here, the placed reinforcements and their drawings. Since there will not only be stair slabs in a real project when you obtain the formwork application drawing, here there will also be many slabs and their reinforcements included. If you would like to view the stair more comfortably outside of the formwork application plan, we have an option here to obtain the stair section along with its reinforcements. To obtain the stair section, when you click on the option here, you will also be able to get the section of the stair. Yes, you can also view the drawings and reinforcements as a section regarding the stairs. Now we have completed this example. Let's move on to our other stair drawing. Our other example here is a straight stair. I will now show how to model it. I will not go into details here, as I did in the previous example. The rules there are equally applicable here. I have previously modeled the beam, polygon wall here. Now I will show you how to assign a straight stair from here. There is one more point I want to mention. As you can see, we have a U-shaped wall. You can model this wall as a polygon wall or with a panel header. Here, the lengths are very important. If the arm lengths here are excessive, then it would be more accurate to model the panel with a header. When it exceeds approximately 4 to 5 meters, it is especially necessary to model it with a panel header. This is because sliding deformations will also become significant. Here, it is also around 4.5 meters. I modeled it as a polygon in this example, but you can also model it as a panel header if you prefer. And there is one more important point I want to mention here. As seen in the architectural plan, we also have an elevator section, and our elevator is connected to the wall from only one side. It's not easy for this wall to stand upright on the upper floors. This wall actually needs to be both in the architectural plan and modeled in our program as a U-shaped polygon wall. This is what is correct from a static perspective. However, this has been presented architecturally in this way. It needs to be discussed with the architect, because when it is done alone, it cannot stand on its own, and here elevators are usually connected to the walls from the side. This prevents that issue. This does not create a healthy model in terms of statics. On the right side, it is beneficial to have a curtain that wraps around these in the modeling with polygon curtains. Modeling it this way is not the correct approach. I have not included this part in my model. I will model not only the stair here, but also the beams, along with the slab that continues underneath. Now, as we come to our program, it can be seen that our polygon wall and beams have been modeled. Let's quickly model our stair again using the same logic. First, I will start with the health slab here. Again, following the same logic, I choose the thicknesses as 15 centimeters and provide the dead load with the live load. The magnitude of the movement is 0.35 as required by our execution. Yes, we have also created our health plan in this way. Now, following the same logic, we come to our macro section. This macro is about. We will create our stair. Here, our width value is 1.2. We need to enter this besides that. With the stair arm button, I will create my stair. In the architectural plan, here, of course, we have corner health options for the landings, and we also have normal health options. In our case, the corner health is visible. As seen, however, I will not create this with the corner health button. When I directly create the stairs, the program will automatically detect this, as you will see shortly. As you can see here, our stair widths will be 1.20, and accordingly, you see that these are 1.20. According to that, I will determine my stair width. Here, it is also 1.20. I will create this stair directly with the stair group button. We created it from here because the previous stair was circular. I am coming this way. As you can see, the right angle section has created the corner right angle itself similarly. I am coming here as well. Right now, the corner right angle here has also been created. And when we press the read button, our stair modeling is completed in this way. You can view it this way. Here, of course, we had selected a flooring remnant of 15 centimeters. Afterwards, these are also 15 centimeters, so it is beneficial to check these as well. Besides, since we created it with a macro, the dimensions of our stair are automatically entered here using the stair option. Here, the regulatory value for our live load is automatically taken as 0.35. When we look at the corner health value, the selected option for health is already being used here, and our moving load value is taken as 0.35. Here, I directly entered this part into the main health section myself, as I did not use a macro. In this way, I have determined the loads. You can change the codes of the stairs. You are able to do that. Of course, here, you can also change the codes of your stairs in relation to the codes. You can change these codes if you think there is a very serious problem with the codes. When you draw, that is, if the codes of the floor are not very compatible, it is because the floor has a certain height. Here, as you can see, it starts from 0, which is what we first drew. Since our last floor is 3 meters, it ends with 3 here. Here, of course, if you are taking a drawing, that does not meet the slopes in terms of floor height. Then you can make some adjustments, manually if you wish. You can change the upper code and lower code here. It's up to you, or if you prefer. We have a macro section here. If you click on the option to adjust the stair codes, you can automatically organize your stair codes using a macro, provided there is a discrepancy in the drawing at that moment. This will adjust the codes in between. To apply the floor code in the stair codes. Yes, these are my comments regarding this topic. Thank you very much for listening to me. I wish everyone good work.